welcome all to the next tutorial in biostatistics about standard deviation. Standard deviation is one of the most important measure of dispersion that is widely used in biological data. Let's see the definition of standard deviation. Standard deviation is defined as the square root of the average of the squared deviations from the arithmetic mean. If you have a set of observations like this, x1 till xn, arithmetic mean for this data is, that is, x bar is equal to x1 plus x2 till xn, the whole divided by n, that is the number of observations, that is the arithmetic mean. And we have learned in the previous tutorials, deviation is variable minus arithmetic mean. So here, standard deviation square. Standard deviation is usually denoted by sigma. Standard deviation square is equal to sum of the square of deviations, that is x1 minus x bar whole square plus x2 minus x bar square plus till xn minus x bar square whole divided by n. This is the square of standard deviation. So standard deviation is equal to square root of x1 minus x bar plus x2 minus x bar square plus xn minus x bar the whole divided by n. That is equal to, this is x1 minus x bar, I have said, that is deviation. So square root of, this is the total of deviations. So square root of sigma d square divided by n, that is the standard deviation. And the concept of standard deviation was given by Carl Pearson. So coming to the equation of standard deviation, I have written here the equation of standard deviation. Standard deviation is usually denoted by sigma, or that is standard deviation is equal to square root of sum of deviations divided by total number of observations, that is n. In standard deviation, this is the equation which we commonly use in calculation and all. While handling the biological data, we have to keep in mind the size of the sample which we take. And if the size of the sample, or the sample size is large, or if you are taking the sample and the difference between sample and population, we have explained in the previous tutorials. If this is the population, this will be the sample. If this is the population, sample is this. That means sample is only the part of a population. So if the sample size is large, the equation which is used is this, that is sigma d square divided by n. And if the sample size is small, that is if the number of observation is less than 30, the equation which we actually use is square root of sigma d square by n minus 1. This is usually used when the sample size is less than 30. And this, I said, while handling the data, this is usually followed. But here for calculation and all, the equation which we use is this. Now let's see how to compute the standard deviation of ungrouped data. Here a question is given which shows the length of 9 earthworms, which is recorded as here, and calculate the standard deviation. For calculating the standard deviation, the first step is, of course, make a table with 4 columns. Make a table with 4 columns for variable. First column for the variable, or x. Second for x minus arithmetic mean. The answer for this, that is deviation. And the fourth column, square of deviation. And you have to complete this table, that is 23, then 22, 20, so on. And in this column you have to minus, that is x minus x bar. So after making a column, the next step is to find the arithmetic mean. Arithmetic mean is x bar or arithmetic mean is equal to, you have to sum this variable, that is sigma x divided by n, that is arithmetic mean, sigma x divided by n. You have to total this, and here you have to complete the table, and in this question the sigma x is equal to 180 divided by n is 9. Total number is 9, so it is 20. The arithmetic mean is 20. So here x minus x bar. So x here is 23. Here the x is 23. So 23 minus 20. Here 22 minus 20. 20 is the arithmetic mean which we got by calculating. So then here d, that is 23 minus 20 is equal to 3. 22 minus 20 is equal to 2. And in the next column it is d square. That is 3 square is equal to 9. 2 square is equal to 4. And likewise we have to complete this table, and sigma d square. Sigma d square, you have to add up all the values which come in this column. That is sigma d square is equal to 16. And then you have to apply the equation, that is standard deviation is equal to sigma d square divided by n. Standard deviation or sigma is equal to sigma square root of sigma d square divided by n, that is equal to square root of this, that is 60 divided by n. N is 9. Then take the square root, and for, because this tutorial is meant for the biology students, but while calculating the square root, what you have to do is, you can use a scientific calculator. First press the square root symbol, that is a square root symbol on the calculator. Press the square root symbol, then put the value. For example, if you want to calculate the square root of 4, press square root symbol, then put 4 and equal to, gives the answer. And in this question, 60 divided by 9 is equal to 6.67. So square root of 6.67, that is equal to 2.58. That is the answer. Now let's see how to compute the standard deviation for a grouped data. For a group data, of course, we'll be having frequency. And here you have a question which shows the weight of 50 fishes is given, is shown here, and find the standard deviation. So first step is to make a table with 6 columns which shows the variable, the frequency into variable. So the table with 6 columns. First one with the variable, next one with the frequency, third with frequency into the variable, fourth column is D, that is equal to the variable minus arithmetic mean, or x minus x bar, and the next column is for D square, and the fourth column is for F into D square. And in this question the variables are 2, 2.5, then 2.7, 2.9, and it goes on. You have to complete this table, and the frequency is 2, 1, 1, and here the next step is F into X. So you have to multiply. 2 in f into x means 2 into 2. That's equal to 4. Here 2 f into x is 1 into 2.5. That is equal to 2.5. Here f is 1 into 2.7. That's equal to 2.7. And the next step, you can complete this fx, and in the meanwhile, after drawing a table, find the arithmetic mean. Where always when doing the deviation, because we are finding how the values are deviating from the arithmetic mean. So the important step is find the arithmetic mean. So next is find the arithmetic mean for this data. The arithmetic mean, because it is a frequency is given, the equation which we use for arithmetic mean is x bar is equal to sigma fx by sigma f. That is the equation which we use, and here the total of sigma f is equal to 50 and sigma fx is equal to 231.1. Then, so arithmetic mean is equal to sigma fx by sigma f. So that is equal to 231.1 divided by 50, and that comes to 4.622. That is the arithmetic mean for this question. And after computing or after finding the arithmetic mean, you can complete this part of the table. That is, here deviation is equal to variable minus arithmetic mean. And so here 2 minus 4.622. 2 minus 4.622, that comes to 2 minus 2.62. Negative 2.62. Here d is equal to x minus x bar. X is 2.5 minus 4.62, that is equal to negative 2.12. Here 2.7 minus 4.62, that's equal to negative 1.192. You have to complete the table, complete the table, and after this, here you have to square, and this part is d square. D is this. D square means 2 points minus 2.62 into minus 2.62. That gives 6.864. If you multiply negative with a negative value, you get a positive value. So 6.864. Then negative 2.12 into 2.12 is equal to 4.494, and complete this table. Then FD square. FD square is F into 6.864. The first part is 6.864 into F. That is equal to 13.736. Likewise, complete the complete the table. Then you can find, after completing this FD square, we can find sigma FD square. So sigma FD square in this question is, sigma FD square is the total of all the values in this column. So sigma FD square is equal to 101.74. That is sigma 0.74. That is sigma FD square. So standard deviation, or sigma is equal to square root of sigma FD square divided by sigma F. That is equal to, sigma FD square is equal to 101.74 divided by sigma F is equal to 50. The square root of this, the answer is 1.427. That is how you calculate the arithmetic mean for grouped data. Now let's see how to compute the arithmetic mean of group data or continuous series, that is with class intervals. While in the mean deviation also we have calculated, while handling with class intervals, the only difference between this, if only the equation which we apply is the same, but the only difference is that we take into consideration the mid values of the class interval. Let's see how to find the, how to solve the question which is given here. The question here shows the weight of 60 fishes and their frequencies, and the class interval is shown here. The class interval is, the first column is class interval. So the first step is to make a column, make a table with 6 columns. So I said the only difference between the previous equation and this is that we have to calculate x. X is the midpoint of the class interval. So the next column, midpoint, that is x. So class interval, midpoint, then frequency or f, then frequency into x, f into x, then deviation, that is x minus x bar, deviation, that is x minus x bar, and finally f d square, f into d square. In this question, the class interval given here is 2.93 to 3.94 to 4.9 and so on. Table has to be completed, and the mid value for this is 2.45. Mid value, and all in previous tutorial it is explained the class interval etc. 2.45, and here it is 3.45, 4.45 and so on, and you should calculate here total midpoint has to be calculated. And the next column, frequency is 16, 13 and 11 and so on, and sigma f has to be calculated. So sigma f here it is 60. Sigma f is 60. Then next part is sigma fx. Sigma fx is this value here, 16 into 2.45, that is 39.2. Here fx, f is 13, x is 3.45. So 13 into 3.45, that is equal to 44.85. Then you have to complete this part. Sigma fx has to be calculated. Sigma fx has to be calculated for finding the arithmetic mean. So sigma fx is equal to 254. So after this much we have to find the arithmetic mean or x bar. X bar is equal to sigma fx by sigma f, that is equal to 254 divided by 60. 254 divided by 60 is equal to 4.23. That is the arithmetic mean for this question. So next part here is find the deviation. Deviation is variable minus arithmetic mean. So here x is 2.45 minus arithmetic mean is 4.23 minus 4.23, that is equal to minus 1.78. Then here again x minus x bar, x is equal to 3.45 minus 4.23, that is again is equal to negative 0.78. Like the table has to be completed. And in the next column, f into d square. has to be calculated. So next step is to find the D D square. The next column D square can be computed. Last column FD square. So D square is the negative 1.78 into negative 1.78, that is equal to 3.168. 3.168. Then here negative 0.78 into negative 0.78, that is equal to 0.608. Then here next column F into D square. D square we have computed here. F is here. The F into D square means 16 into 3.168. 16 into 3.168 is equal to 50.69. Here also this part frequency is 13. 13 into D square, that is equal to 0.608. 13 into 0.608 is equal to 7.904. The table has to be completed. Sigma FD square. You have to find here the sum all the values in this column and sigma, that will give you the sigma FD square. So sigma FD square is equal to 130.198. 130.198 is the sigma FD square. So we'll substitute all the values in the equation. That is standard deviation or sigma is equal to square root of sigma FD square, square root of sigma FD square divided by sigma F, that is equal to square root of 130.198, that is sigma FD square divided by sigma F is 60. Then I said press square root symbol on the scientific calculator, give the value for which you have to find the square root, and that gives 1.473. This is how we calculate the standard deviation for continuous, for the grouped and the ungrouped data. Now let's see what coefficient of standard deviation is. Coefficient of standard deviation is the ratio of standard deviation. That is, it's a ratio of standard deviation to the arithmetic mean. Coefficient of standard deviation is equal to ratio between standard deviation to its arithmetic mean. So for the above question which we have calculated the standard deviation is 1.473 and the arithmetic mean was 4.23. So here that is standard deviation divided by arithmetic mean and the value is 0.35. That is coefficient of standard deviation is the ratio of standard deviation to its arithmetic mean. That is coefficient of standard deviation. Now let's see what are the merits and demerits of standard deviation. Standard deviation is a rigidly defined one which has got very good application in handling the biological data, and it summarizes the deviation of large number of observations from the mean or the arithmetic mean and is expressed as one unit of variation. Then it is less affected by the fluctuations which usually happens while collecting the samples, or while the fluctuations of sampling is less affected in calculating the standard deviation. These are the merits, and coming to the demerits, it requires a lengthy calculation and not very simple to, it's not easily understood, and the calculation gives more weightage to the extreme values. Thank you.